But basically, if you want to make an observation that would duplicate either an existing, an archived observation or one that is planned, approved and planned, then you have to justify it in your proposal. And you might ask, well, so an observation duplicates another if it is on the same astronomical source or field, using the same instrument in the same configuration, which is to say the APT template, and has a similar sensitivity and spectral range. And you are responsible for checking your proposals. Now, I'll say that evidence shows that in general, people are really very good at doing duplication checking. We've had not that many instances where there's been a failure, and those that do occur often, it doesn't help because they're within the same cycle. That said, it's true that in this cycle, we now have more observations in the archive and many more planned observations. So the number of chances you've got for duplicating is increasing with each cycle. So all that is the same. What's new is that the Web Mission Office of Mass has developed a new tool that's optimized for finding observations. And it's optimized in the following sense, that you can check based upon the APT observing template, and that template really is a shorthand. It specifies the instrument, its configuration, and its data taking mode. And so you can match to that, and the database it looks at is the basically the program plan observations. Right? So it's not just looking at the mass database of archived observations. It's looking at the totality of it. These links should be helpful. There's the search tool, which I'm going to demo here in just a moment. The documentation for that tool. And of course, the policy, you'll want to take a look at that fairly carefully. And it turns out that the MASS portal is still useful for some purposes in this regard. I'll explain about that in just a little bit. So here's a screenshot of the interface with some annotations on it, boxes labeled 1 through 4. Basically, it's pretty simple. You search for a named target or a set of coordinates with a search radius. You specify the search parameters that align with your intended configuration, and then specify additional constraints, which we'll talk about here in a moment. The fourth box will show you the fields that is in the results table you're going to get. These are the fields that will be displayed there. There are more fields available, and you can pick them or you can delete some, depending on what you're looking for. Just a couple of notes on strategy. And this is intuitively obvious, but I'll mention it here, perhaps for new observers. Limit the initial query to a particular fixed source or set of coordinates, but without specifying the other criteria. If there are no matches, then there's no potential for duplicates. Now, this applies only for fixed targets, not moving targets, of course. On the other hand, if there are too many matches, try searching for one target at a time. That's just to avoid confusion in the results table. Use a generous search radius for fixed targets, at least as large as recommended in the duplication checking and review procedures, which for imaging cameras is a few arc minutes, and for spectroscopic apertures is much smaller. You may want to increase that radius for small aperture observations if you have a high proper motion target. For solar system targets, you'll want to specify a moving target type and use specific search fields to match the target name. Searching by target name has its own issues, and we'll talk about that here in just a moment. Now, initially use the default of all the templates and all program types and status values. You want to search for the wide net in your area. If there are matches, then narrow the search by specifying these other attributes that will match what you intend to observe. And if there are still matches, then you've got something to do, which is, justify the duplication or look in detail at whether the potential duplication is genuine. In the end, though, the APT files of planned and executed programs, which are all available online, these are the ultimate basis of comparison for observations you planned that may duplicate. And let me do the demo here. So this is the interface. I'll go through a couple of examples here just to give you a sense of what it's like. I often search for M57 and sometimes I mistype it, but let's just type that because I happen to know that in fact there are no observations that match that. But this is the first thing to do, right? It's just a sanity check. Is there anything to worry about at all? Anyway, you can see the parameters that you've entered in the top box. It says columns. This is just a table listing each of these attributes, and you can study that at your heart's desire at a later time. But it does help actually to look at the template, optical elements, and everything else, because when in the next step, when you actually check particular templates or all that, this set of results will actually help you understand what their names are. Now, this actually matched. So I made a mistake here, but this is illustrative. I'm going to show you that. So I had M75. I have to hit return here. That does the resolution. And so if you search for the target now, this is why it took so long, it will actually do a search and show that there are no results, no data available. Right? And you can see that here at the bottom of the page, rows per page, there's navigation, and you have just no results. So let's go back and type in the correct target. You can search for multiple targets at once, which I'm not sure if I recommend, but you can do it. And 3 arc minutes is actually, let's do that. M57, are there any observations for that target? And you'll find that there are quite a few. And so then the question is, well, okay, so maybe I want to observe M57, but maybe do it in a different way than it had been done before. And our server is taking its sweet time. Oh, because I made a mistake. All right. You would think I'd be better at this after all the practice. All right, let's go edit it here because you have to enter the thing and hit return. There we go. All right. So to save a little bit of time here, we'll just take a look at a template. What I really want to do is observe in one particular mode. So let's select no templates and go for what I really want to try, which is medium resolution spectroscopy with MIRI. That's the MIRI IFU. So we select one template and do a search. Now we're getting more and more specific about what I want to do. And here's, the optical elements. These are just basically order sorting filters. And you'll notice, by the way, there's a link here. So the first field is the program. And if you click that link, what you'll find is that it brings up the observing status for this program. And if you want to look at the PDF of the APT file, you can look in infinite detail, or you can look at the APT file. You can look at infinite detail of what was done to know specifically if your observation duplicates. Now let's try something more exciting. All right, so let's do a solar system target. And so we want to add a condition because we only want to look for moving targets. All right, so how do I know how to search for that? I'll just type moving. Target type is what I want, so I click that. Now I'll click it and hope it sticks this time. There we go. Target type and the condition is moving. All right, so we have that condition. Now it turns out there actually aren't that right now. There aren't that many moving target observations at all. JWST is pretty young, so we get this set of results here. And take a look at target name, because that's the thing we want to select on. And you'll notice that target name and standard target name might be something you recognize, and it may not be something you recognize. Target name is provided by the observer and the APT file. They're also asked to provide a standard target name, but often there are annotations here that make searching a little bit more interesting. So let's edit the search. and add a condition for let's do a standard target name. Now remember that static target name can have a lot of other stuff around it, but suppose we want to type look for a particular asteroid. Hopefully I typed it correctly. Notice I'm putting in asterisks here. That's wildcards. So if we search, we should find any target with the name Didymos in any of the target fields, and indeed we find them. Now, the table has a bunch of other stuff in it. Things like phase, critical period, and starting phase and all that really apply to time domain and not so much for looking for solar system bodies. But anyway, so you see that it's possible, and there's a longer explanation for this in the documentation. But you see it's possible to use the target type. Another way you can do this, by the way, is to add yet another condition. This is a little redundant. Level 1, that's not level 1 as in the data file that comes out of the pipeline, but it's level 1 in terms of searching for moving bodies here, solar system bodies. And we do a search. We'll see a similar result, but you'll see that level 1 is a category. If we search for level 2, we could actually have looked again for the name of the target, but we've got it here with the standard targeting. So there, you have more tools in your toolbox now with this search tool to find objects that are a little bit more difficult in other tools. Now, I'll have to give you some caveats here. Let's see if I can restart this. Caveats. There are caveats to any tool in identifying not just potentially duplicate observations, but genuine ones. Target names are a problem. We just went through an exercise here to show what the effective strategies for searching for targets by name. Just be aware that the target names can have annotations like M57- background or whatever it is. The names are not vetted. The geos specify that in their proposals, but we don't check that the target name is in fact standard. And the impact of that, as many of these are, is that it can lead to false negative results. Oh dear. Targets with high proper motion can be another difficulty if you're using a small aperture. The ICRS positions as yield by a SIMBAD will not match the coordinates of your future observation. If you look in the mass portal, you'll see that aperture footprints and mass correspond to the epoch of the actual corresponding observation. That is the time it was taken, not to the date of your search and not to ICRS. The background survey in the mass portal corresponds roughly to the mean epoch of the survey, not ICRS. The exposure duration is another weakness of this tool currently. It gives you, let me show that again here. It actually gives you an exposure time. It would have given you exposure time. Where is it here? Probably it's, I have to ask for that specifically, so let's do that. Exposure, here we go. Do the search again. These exposure times correspond to an example exposure, not to the total duration of say, a dithered combined image. I don't know. Oh, here it is, exposure. Anyway, so that information is just not available on this tool. And you may say, well, what can we do about that? by the way, here's the web page for the documentation on this. All that I've said is pretty much in there. You can use the MAST portal to do a similar search. I've looked for M57, the radius of 3 arc minutes, and it shows other information. It's less good at searching with a specific instrument template, but it is good at showing a couple things. One is that it can show you all the footprints for every observatory ever. That may be a little confusing, but if you limit it just to JWST, it shows you the spatial footprint of every observation, which may be informative. And for combined products, it actually will, if you edit the column and show it. Okay, that's exposure duration, exposure length right here. Okay, here it is, exposure. This is the exposure time in seconds. This is for the combined product, right? So that actually is useful if you get to the point where, hey, your target's observed, it's in the same configuration, you know, exposure time I had in mind is this. If you want to go much, much deeper, a factor of 3 or 4 deeper, maybe you're okay from a duplication checking point of view. So this just illustrates how other tools, including the MAST portal, can be helpful in this process. And here on the last page, let me just show that. There are other tools that, aside from the duplicate observation search, this just shows their strengths and weaknesses, what they will give you, what they won't give you. And between those, you get a pretty good idea. But ultimately, looking at the APT file is the ultimate source of truth. It's just that you don't want to start trolling through APT files unless you're pretty sure you need to. And that is what I have for you.